So maybe a raise of hand. How many people have been here all week, or at least Monday or Tuesday? Okay, who here have just come in, for today's meeting? Okay, so good mix. So I'll kind of give a quick, overview of ESIG and of what we have planned today, just to give you, a quick view, and then we'll go right into our first panel of the session here today. So today's workshop, the theme is on advanced grid solutions. That's kind of an ambiguous, vague term that we've been using as part of one of our users groups at ESIG, the Advanced Grid Solutions Users Group. And what is we tried to think of the right term to capture both software and hardware solutions and technologies that are used to help deliver power, to help grid operators operate the system, the types of tools and solutions and algorithms used to plan the system, to run the electricity markets, all of these types of technologies that are used for, sort of beyond the supply side, but, just really, running the grid. And so that includes things like grid enhancing technologies, which we'll talk about today. It includes AI and power applications, which we'll also talk about today. A whole other suite of software technologies that have been emerging that we'll also have some topics on. And really the importance is that list of solutions is growing, and what we want to do as part of this effort is to bring utilities, system operators, other types of users together to share their experiences, to share the lessons learned on using these technologies from pilot to full implementation and everything in between. So this is really the first year that we'll have a workshop on the topic, and that's kind of what the goal is for throughout the day today. I'm going to really quickly. There's just a lot of words on here, but many of you probably are familiar with ESIG. We're a collaborative organization. There's well over 300 members. It was formed in 1989. We're really focused on bringing industry together to help solve technical challenges related to how we integrate new technologies onto the power grid and in many cases the broader energy system. So that has to do how we do that is through peer learning workshops like we've had this week, as well as more specialized topics and task forces where we put together products that can help policymakers and those within the industry with particular recommendations on how to solve some of these difficult problems. It's just kind of a makeup of the members of ESIG. And of all those, another big chunk from the supplier side, the developers and independent power producers, and then a lot of other entities, the folks providing some of the tools, both hardware and software, those that are doing the studies, and even a growing portion of some of the regulators and government entities that are listening in to make sure that they have all the information that they can use to make decisions. That's core to what they do. These are the working groups, the technical working groups at ESIG. They're kind of split into these four categories. Really, today's workshop is kind of spreads across all four of these, but most importantly, on the smaller print below, you see the users groups being sponsored by, and that's the Advanced Grid Solutions Users Group. That started several months ago with support from the Department of Energy and Idaho National Lab. So thanks to Jake. More of a roundtable and an informal discussion with that group. And I just also wanted to acknowledge Michael McCamus from TVA and Chong Wang from MISO, who are our two co-chairs of that users group. So the idea of this workshop, again, is to have the public version of what we discuss as part of that users group. And I mentioned those types of technologies that we talk about. Lots of e-cig disclaimers here. What I'll mention, so what we focus on in e-cig workshops um, is inclusivity, making sure that everyone has an opportunity to ask questions, no dumb questions, and um, lots of other things, including antitrust compliance, which I'll say not to. Um, and also we have very strict non-discrimination, anti-harassment rules that we take very seriously. So just something to keep aware of. So today's the last day of the 3-day e-cig summer workshop. So in the other room, they also have a flexible interconnections for large loads. Probably a lot of overlapping topics. Good thing is we do record all of these sessions. So if you're having FOMO, you really want to be in this room, but you kind of like some of the things in the other room, don't worry. They are being recorded. You can listen to them on your next flight back, or maybe a couple days later. I know I'll be trying to do that myself. And I'll also mention that this evening, if your flight's not till tomorrow, the ENCORD is putting together a social event this evening, so should be a fun time there. This is what we have for the agenda today. So Jake's going to kick us off with this great panel that is really kicking off, the entire workshop of today by not being specific to any of the technologies that we include in the advanced grid solutions category, but more about how do these companies think about bringing innovation into their company, into their planning, into their innovation groups, and into their operations teams. Putting together roadmaps, putting together pilots. What are the types of things, white papers that sort of explore these technologies, and then getting to actually implementing them is really what we'll talk about without getting, we'll probably mention a lot of the technologies, but this isn't a specific technology session that we'll get started in. Really great session that will happen after the break that's really focused on AI and power systems, kind of a two-part session to get us up to speed on what's happening, that then also talk about what else needs to happen. So looking forward to that as well. After lunch, we'll get into grid enhancing technologies and advanced transmission technologies, what types of frameworks are being put together. We had a great discussion on that in the user group yesterday afternoon also. And then the last session for today, talking about what are those other sets of technologies that maybe aren't quite being implemented or aren't quite on the radar of utilities and system operators today, but they should be aware of them. They're the types of things that they're ready today, or maybe they're ready in the next few years, and we want to ensure that the folks that are doing this work, the startups, the research organizations, are able to answer some of these questions, and that you're able to ask them some of the questions on, hey, is this really ready? Is this really prime time? Is this something that we can trust, that we can start building into our system? So that'll be a great way to as our last session of today, and then the user group chairs, Michael and Chong Chong will close this out for today, really kind of talking about what they heard, and then sort of what's next with that users group. I guess my last thing I'll say, if you are a utility system operator in the room, even a generation company, and you're interested in joining this users group, let myself know, let Michael or Chong Chong know, or James from eSig as well. We'll get you included in that. We have monthly virtual calls on different technologies where we invite people to kind of share their experiences. So that's something that will continue to happen throughout. So anyway, thanks for listening for that quick introduction. And now I'm going to bring up Jake to introduce the first panel. Really looking forward to this. Jake, introduce us, and looking forward to a good discussion here to start us off. Thanks all.
All right. Appreciate everybody joining. I'm going to jump right in. I think the opportunity here is to let you listen to the experts. And I think we've got four esteemed colleagues here that are going to give you their insights to to what this topic's all about. I'm Jake Gentle. I'm from Idaho National Laboratory. I've been working in this space for well over 15 years. Dynamic line rating, power flow control, topology optimization, advanced conductors, various things. The opportunity here is to really put this into the hands of the industry. I think we've been piloting and studying and doing things for many years now. It's time for it to get used. All right. So today's conversation really should have that accelerate, innovation to adoption. The adoption part is really what we want to focus on. So I'll kind of lead off with this is we've got 4 great panelists here. They'll go in this order. So Jay Hastings, Executive Program Lead at Arizona Public Service. Prashant Kansal, Director of Grid Transformation at ERCOT. Carrie from Department of Energy and Office of Electricity's Applied Grid Transformation Program. And Dee Dee from California ISO, who's the Vice President of System Operations. And with that, I'm just going to jump right in. Jay, I'll let you come up. Keep the introduction short so we can get to the meat.
All right. All right, let's see if we can figure this out. All right, so how do I start this timer? Okay, it started. Great, fantastic. Lots of cool devices. Okay, can everybody hear me okay? Yes, okay. All right, so as Jake mentioned, my name is Jay Hastings. Work for Arizona Public Service. I'll go into some of my details here in a second. I did want to mention it's really nice to be back in Denver. I grew up here, so grew up going to Mile High Stadium, going on the bleachers. It's a really great town, so glad to be back. I did want to say thank you to Eric, to ESIG, and having me here. It's a great opportunity to share some of the perspective that maybe Arizona Public Service has that's helpful for how we think about some of these items. All right, so before I get into my introduction, I'd like to kind of highlight a couple things that I'll talk about throughout this presentation. But 2 billion people, that as a number, and 20 gigawatts. So I'll get to what those mean, but 2 billion people and 20 gigawatts. So my bio. So I want to have the context as I walk through this of where my lens is. So I started in the Navy and the Merchant Marine, came out of the Merchant Marine Academy, and my background was on running power plants. Ran power plants for about a decade, and then I went to Palo Verde Nuclear out in Arizona and was there for 17 years, working through the different parts of engineering, different parts of operations, load and fuel, all sorts of cool stuff at Palo Verde, which up until a couple of years ago was the biggest nuclear power plant in America. Now Vogel's overtaken us, and when I went to Vogel, they were happy to present me with a trophy that let me know that we were second in the country. So that was very nice of the folks at Vogel. But part of my intro and what I wanted to say is that I'm not an expert in all of these innovative ideas, the technologies that everybody's thinking about. My role and what I'm going to talk about here is how we think about all those things as they're brought into the fold, as we talk about them, as we think about them. How do we move them from an idea into our operational way of working? How do we move it into that cup of coffee that you reach for in the morning and it still gives you that nice caffeine hit and you wake up and you get that feeling? If you didn't get that caffeine hit, you probably wouldn't drink the coffee. So how do we move that? How do we think about that? Okay, so this slide is the most recent slide I could find. I had a chief nuclear officer at Palo Verde that used to show this all the time, and it gets to the 2 billion number. So when you look at this, what it's trying to show is a dot is 1 million people. So when you look through there, you got some, looks to be yellow dots, orange dots, and red dots. When you get to the red dots and the orange dots, that's unreliable power or no energy access at all. So that's 2 billion people. So I highlight that, and why we used to talk about all the time is to say that as we think about these innovations and we go forward with how to incorporate them, what we have here in the yellow dots in first world countries is very reliable power. When you turn on that light switch, the lights come on. In Arizona, when the air conditioner kicks on, it needs to kick on. Yesterday was 110 degrees. So we need to have that air conditioner kicking on. And I'll talk about some studies later that have to do with that. But it really highlights how well we do our jobs and that what we do is very, very important. And if we don't do it well, then you can end up like the red and orange dots. So that's the world scale. When we look at Arizona, I always think it's interesting the context of timing. So shows here 1886, so that's up on the board. But just a few years before that, in 1881, if anybody watches movies, I love movies. Wyatt Earp was down in Tombstone having a gunfight. So while we're having gunfights, in 1876, what started was Major League Baseball. So in the East, they're playing baseball. In Arizona, we're having gunfights. And then in 1886, we figured out that probably Phoenix needed some power. At the time, there was about 2,000 people. And we didn't start as Arizona Public Service. We started Phoenix Illuminating Gas and Electric Company. But the context of those 140 years is that, as you look at this map, our peak demand last year was around 8,600 megawatts. Now, we're also partners in the state with Salt River Project, who I think there's some Salt River Project folks here, and also Tucson Electric to figure out how to add up all of that need in the state. But for us, 8,600 megawatts. And today, right now, to my 20 gigawatt number, 20 gigawatts of Q is sitting out there for large loads and data centers. And they want to get into that demand for Arizona. And SRP also has a number that is in a queue, and we have to figure out how to serve them. So you look at that and you look at over those 140 years, the largest customer that we had during those 140 years was a 75 megawatt mine. As most of you know in the room, large load customers are much larger than that. And right now, we even have a huge customer that's pretty vital to our state and pretty vital to the country in TSMC. They're already there, and they're already doing work. So how they ramp and how we serve them while not compromising the reliability we showed on the other screen is a big piece of this discussion. All right, so this isn't supposed to be a promo slide for APS, but it gets back to what we think about from the context of what I'm going to talk about. So my role, to get back to executive program lead, which is a slightly made up title for our company, it just was started with me. When I left Palo Verde and I left as the plant engineering director, I was asked to go down to corporate and learn from our chief operating officer all of the corporate side. So for the last 18 months, I've been learning and observing from our COO and our CEO, CFO, all parts of the C-suite. And I say that to bring up the idea that the context for the like we showed with the entire world, if we don't do it safely, then it doesn't work. If it's not reliable, then it's not going to work. And if our customers can't afford it, then it's not going to work. So you have to check those boxes at a high level every single time you walk through the algorithm, the path, I think, as Eric mentioned, to walk through that path of decision making. And I'll give you an example of something that from my past that'll show you why that's so important. If anybody in here, so I was born a few months after it, but in 1979, there was an event that happened at 3 Mile Island. 3 Mile Island shut down the nuclear industry in America for basically 40 years, as far as new power plants being built. So if you don't do it safely and it makes the news, that discussion, EEI 2026 that just happened, they talked about a lot of these same things: affordability and value, the change that we have to deliver faster, we have to be simpler with more scalable ways to do it, expanding the meaning of resilience, grid hardening, cybersecurity. One thing that we talk about with TSMC that's close by to us is TSMC obviously is from Taiwan. And one of the items when we look at large load and data centers and how we can handle that load is that China has a 50-year plan. And they have 7 core structures that they build with that plan, energy being one of them. And the point of the plan is to dominate That's the point of their plant. And so when you look at that, they're building nuclear reactors. I think they've got 34 under construction. They're building solar, everything that they can build. So this is potentially a matter of national security because China is right at all of our firewalls. So that's a real thing. So cybersecurity is a real thing. How do we create solutions? How do we, another thing that we think about all the time, we work with Arizona State. I know there's some Arizona State folks here. How do we work on that workforce of tomorrow? What are the constraints? And the whole focus overall from EEI was that delivery, defining the moment for the industry, and the challenges ahead are vital to our success. So now into our decision making, not the promo slide that I have here, but how we go through our decision making is we look at it and we want to make sure that how do we look at these investments? How do we look at the options and de-risk them? How do we set on that best path? They have to be defensible, durable. We're going to pressure test them, sensitivity analysis. And I think it foundationally look at it and you say there's a 3P principle that I think about. This is not from how APS talks about it, but you got to have the right people. You got to have the right processes. And fundamentally, they have to be in the right priority scheme. If you're trying to do everything, which is what a lot of the innovations, there's a lot of things going forward. If you're trying to do everything, then nothing is a priority, as the normal conversation goes. But most people, like get back to that workforce, they don't think about how much this takes, the talent, the skills, the technical knowledge. Like I said, every time you turn on the light switch, this is 24/7 operation. So making sure that how we run the business, how reliable that is, that cannot be compromised before we start making these technology choices. All right. So we'll get into some of the things we think about from Arizona Public Service as far as our all of the above approach. I think that at the starting point of this, you look at it, and I think AI has just expanded to a thing where it's essential to everybody's core business. I don't think anybody in this room is doing anything without some sort of AI. I'm Googling it all the time. That's what I'm going to say Google, but I just type into my browser pretty much everything, and it sources so many things at such speed that it's incredible. Matter of fact, Liz and I were talking about AEIC's Data Framework Working Group for Thursday, so we'll be doing some AI examples tomorrow. But as far as AI, some examples that we've got right now going on for Arizona Public Service. So at Palo Verde, we've introduced NovaChat. NovaChat is something that took all of our data that we had. Nuclear's very manual. Everything's very manual. Everything's on paper. Got that into the right warehouses, cleaned it up so that all of the operational efficiencies sped up. All of the operators now can validate and check their systems before they go to the field. They were doing that all manual with triple redundancy. Wildfire risk. We learned a lot from California over the recent couple of years. We've had our own big wildfires at the Grand Canyon last year. 10 years ago, we didn't have a comprehensive wildfire mitigation plan. Today we do. We have meteorologists on staff and how they use AI cameras, we're finding fires before any fire department does. So that use of AI. This year we called our first public safety power shutoff. So we looked ahead, we said, is the wind speed, is the humidity, is the temperature, is all these factors into the algorithm that make the most sense. And some areas near Flagstaff, we had to take the power off. Wasn't great, but that's a decision to help prevent wildfires. I've seen some control rooms of the future. Again, my Vogel example, I got the chance to tour their control room. It looked like a video game. So that's pretty cool because I like video games. If anybody else was an 80s, 90s kid, you grew up with Nintendo, love video games. So it looked like a big Nintendo. It was really great. And I talked about one of the things for innovation that I think is important past the AI and part of this discussion. Had the chance also, Arizona State, the Executive Advisory Board. Recently, we were talking a few weeks ago about how to get the engineering programs faster to scale. How do you get this industry faster? Because they brought up that when you get innovation, somebody comes up with an idea, say at a university, somebody presents that and they start to get that published. It's 35 years typically to market scale. We can't take 35 years for the innovations we're talking about today. We have several other things, how we scaling up our battery, our solar. But basically, I knew that I would be running over time, and I tend to babble. Wanted to make sure I got to kind of the conclusion and let everybody else kind of weigh in on these different thoughts. But we talked about it. All of these things, the 2 billion people that have unreliable energy. Wanted to quickly reference, there was a New York Times study just to kind of drive this point home on the reliability aspects. 2 days of an electrical grid failure during a heat wave, 110 degrees in Phoenix. It was 110 yesterday. Not sure what it is today. 12,800 people would die in Phoenix, just Phoenix. 800,000 would require emergency care for heat-related illness. 3,000 emergency beds overwhelmed. So overall, how we run the businesses has to stay perfect. How we now change the business has to work its way into that reliability, that safety, and that affordability for our customers so that we don't end up in that unreliable space. Because right now, the demand is here. It's not in the future. It's here now. Things have changed. And so now for this group, how we step up to that challenge is how our future will be determined. Thank you.
Hi, everyone. I'm Prashant Kansal. I'm the director of grid transformation team at ERCOT, and I'm going to talk about why the grid transformation team now and what are we working on. So for my background, I just joined ERCOT 1.5 years back. I used to be at Tesla leading their power systems team before ERCOT. I also worked at American Electric Power in the advanced transmission studies and technology team, working on various topics there. Previous to AEP, I worked at Schweitzer Engineering Labs and Protection and Controls. And back in my early days, I started with oil and gas. And so I've been doing power system for some time. And as you sort of watch this movement of how the grid is evolving, it was very interesting to me that ERCOT felt the need of having a centralized innovation team that is working with different business teams to push some of these ideas forward together. And I think if you look at these change drivers, right? I mean, so grid is physically changing, right? That is one fact. It is changing from, I mean, in terms of how it was maybe in 2010, it was synchronous machine, and with generators being the big guy and loads being the small guy. Then the renewables came in, and industry figured out how to sort of take IBR into account in the planning, and how to forecast them, and so on and so forth. And that's all power electronics. So inherently, grid shifted from synchronous machine in generation to power electronics in generation through IBRs. And then batteries came around 2018 and 19 timeframe. And then the large load started to come, which is again power electronics. And the game shifted there quite a bit, if you think about it, because all the grid philosophy has been designed around large generation and small loads, meaning you're prepared for voltage going down, you're prepared for frequency going down. With a large load, which is maybe 5x your typical generation size, you have to prepare for voltage going high, frequency going high, right? And also load being in one place, how does it change power flow on the grid? How do you manage stability of the grid? Those are big questions to answer, right? And these are all things tied to the physics of the grid, right? Underlying physicality of the grid. So in essence, and also DER, I think that's a big shift, which I would say we have not seen that much of that in America right now. But if you think about Australia, you think about Denmark, those countries are almost at 100% penetration of DER. Like for Australia, it's a 40 gigawatt grid with 24 gigawatt solar rooftop. Denmark is almost 100% in DERs. So physically, it has changed a lot in a very short time, right? Also, the technology now that you need to run the grid, right? All the simulation platforms, all the new techniques that you need to run the grid. Plus, obviously, AI is here to also you can infuse AI in anything you want to, but how, right? And how much, right? And when can you trust it? So those questions are, if you zoom out and think about it for a second, and to what Jay was saying, like, and you have to do all of this reliably, right? So that is like an ocean of problem statements to solve, right? To sequence them, like what problems do you solve right now, right? What problems do you wait 2 years? And you have to do this while you cannot just bubble up your team suddenly and throw people at it and it just solves. It doesn't work that way. It's because a lot of these problems are complex. Like understand these problems take a lot of time. Like what is the true problem behind, right? So point being, it's a very that you have to be very thoughtful about it. Like, for example, like when we are working with business teams, they're heads down busy in many things, right? To get time from them while you're doing a metrics organization of innovation team is hard, right? And you have to like find time how you push things while the business is running at its own pace, right? So um, so combine all the factors that I mentioned. I do think ISOs utilities would see the need of doing innovation, like maybe as a centralized work. At least in the moment I'm not sure if it is needed like forever, but at least in the moment we are, it feels like there's a need like that. So that was my excitement to honestly join ERCOT in that moment. So this is like our vision is to sort of work with different teams and bubble up. And ERCOT itself has a vision statement to be most innovative and reliable ISO in the world. And to that vision, we are working with our business team and digital team together. And how ERCOT has set up this team is now we have a CTO team within ERCOT. So I report to the CTO, and we are working both with the business. By business, I mean market planning and operation, and the digital team, which is the team that is providing the tools to all the business team to run the analysis. So so I think I mostly covered this, but the three things that ERCOT really is focused on right now is making sure we are that independent expert voice in the industry, and develop innovation through the people in that process, and also like to the end goal of being most reliable and innovative grid in the world. So now the $1 million question is how do you figure out what to work on, right? So in ERCOT, by the nature of the business, by the nature of we being nonprofit, we being the ISO in Texas, and Texas being the sort of the energy state. I used to be in California, and when I moved to Texas, I could feel it. You being in Bay Area, you feel like the software. You hear softwares and all the party. You go to Texas, you start to hear some energy, and then you also feel like how the whole ecosystem is set up between the state and ERCOT, PUC, and all the market players. So there's an energy vibe in ERCOT. So you get a lot of ideas, especially being the ISO and the nonprofit ISO structure that up by these ideas. So one thought process was to start centralizing some of these ideas intake. So I meet all the directors bi-weekly within ERCOT. We also meet every 6 months with our whole executive leadership team, with our SMEs. And then we do a lot of internal surveys and a lot of internal discussion that is happening. And then we also created a program called RIPE, where anybody can submit their idea to ERCOT for the innovation. And then we are trying to bubble up those ideas through this process where we are looking at all these ideas and saying, do we understand the problem or not, right? And if we understand the problem, do we understand the solution or not, right? And generally, if we understand the problem and the solution both as of now, then it should be operational problem. It's just waiting for resourcing to happen, and we should just solve it. Document for the RFP. And once you do the RFP, you need to understand the proof of concept, and then you can operationalize that technology, which has its own challenge. How do you go from proof of concept to operationalizing? Because that is something we are learning on the way. But maybe I can talk about that later. This is the industry where, again, I've worked for OEM before, so I know how OEM works, right? It's a very different game. When you're in a nonprofit stakeholder-driven process, you just can't go and do things. You have to like wait for all the stakeholders to come on board, right? So it's a different way of doing things. And, sometimes, from the OEMs and I coming from my side, from that part, I can hear some people can feel why it is not moving that fast, but it's a different world, right? So, and it's a different world for a reason. So starting criteria and stopping criteria. So if you have done something that has defined the problem and you have a solution in mind, it should go back to the operation, in the operation world in a sense. So and this is what it is, because we don't want to decouple the stakeholder process, obviously. So this is almost like feeding into a stakeholder process, which is already existent, right? So we have all these working groups and stakeholder working group. So our idea is to sort of pre-package that solutioning and problem statement definition, and then bring it to the stakeholder process so that we have a very clear reasons of saying what we are saying. So that process on the right side is all where it eventually feeds. So it's but when the process of finding the problem statements and solution is sort of what we have kept independent. We are keeping our stakeholder and POC up to date on what we are doing, but that's pretty much it. But we're not sort of bound by stakeholder defining the problems for us, right? Because that is something ERCOT can see internally ourselves better. So I think just a couple example of what are the type of problem statements that rise up to be a grid transformation initiative is, for example, reactive power optimization. Historically, industry did not have to really bother too much about this problem statement. But as the power flows on the grid is changing, as the IBRs and all power electronics based devices are coming on the grid, we will have to think about how to make sure that we solve for voltage at all times, and we solve for voltage at all times in future with the optimal solution of how do you move the taps, how do you move the set points on the voltage with a look ahead view of it, right? And that's a hard problem to solve. As you know, a lot of look ahead simulation platforms are megawatt based, including reactive power in it. Like, it's a hard thing to do. So that's a problem statement that risen up to be a grid transformation initiative, because we understand what problem we are trying to solve, but the solution is very hard. So that's why we took up this problem statement. We started with a white paper, and then we did a POC. And the thing that we are learning now through this process is, even if after you finish your POC, there is a lot of work after that to understand how to operationalize, how to say this is successful enough, right? And sometimes it's hard to define that in the moment when you're running the POC. There's a lot of afterthought of what it could have been. So we are going through that process. We might onboard maybe more vendors, look out for better solutions, but that's a process we are going through. Because again, from the reliability perspective, when we push the solution to our operations team, eventually it has to be working, right? It just cannot be we cannot leave it to the experimentation to the operation, because they don't have time for experimentation in the moment they're operating the grid. So so that is one. The second one is DERs. We have 6 gigawatt DER in Texas right now for an 85 gigawatt grid. So in a grand scheme of things, it's not that much. But at the same time, we have VPPs that we have several VPPs. We can see there is a movement to have more VPPs, and the companies want to scale. So we know there is a natural push for more DERs, and we look across the world. I think the DERs are going to get pushed because of the cost, and there's a desire to have your own generation at your rooftop. In most cases, if the prices make sense. So there has to be a thinking about how do you get the data from DERs in a cost-effective way, right? There are various ways to get data, but then how do you get it in a way that people can actually sustain that cost, right? Which is, how do you use the API-based technology once you have the data? Which organizations can you feed? Which, like, is it market? Is it operation? Is it planning? And each have a use case in it. So who will be the business owner? So there is a lot of thing underlying before you operationalize this. So that's why it rose up to be the grid transformation initiative. And in this case, I would say the problem was less known, in a sense of what communication technologies out there, who can actually provide, what ERCOT need. There are a lot of dumps platform out there, but we don't need a dumps platform. Because we don't want to close loop control with DERs. We just need the situational awareness and feed our planning processes and markets and other teams. So yeah, so it's a similar process that we went through between last 2-3 years. And as you can see, like even starting from a white paper, we are already in 2026. We finished the POC. We are trying to figure out a way how to take it to the next step. Like the whole process is taking like 2 to 3 years, right? So there is a preparation time for innovation to really seep in the organization, right? And even before you kick off the initiative, there's a whole almost 1 year process while we are marinating all these ideas through these ideation meetings that we do internally in ERCOT to figure out what should bubble up. So I would say almost to get an idea from the state where you're talking to the things that is something delivered, probably it's like 3 to 4 years. And so I think maybe that's probably important takeaway, and at least as I think about these initiatives, is it's a long time in making for various reasons. So overall, like what are the things on the plate right now? So we are working on things around how do we optimize batteries, because we are 20 gigawatt battery for an 85 gigawatt system already, and we are relying on them to meet the evening peak load. So we have to be like careful that we have a way to understand where the battery state of the charge will be. And if we think it will not be at a place where it needs to be, then we have to maybe figure out way how to get it there. So that's what about the ESR energy optimization is. Getting the DER information, we are also looking at, we have a lot of meter data in ERCOT. So ERCOT is unique in that we get meter data. So there we are looking at AI tools to disintegrate that demand into different equipments to understand if there's a potential for demand response, right? Which is already a discussion in ERCOT, but we don't have visibility right now, as of now, like precisely how much heat pumps we have, how much PV we have, how much EV we have, and we are trying to find ways to use AI for that. System strength and inertia in real time measurement using PMU or other techniques is another thing we are looking at right now, because we do measure inertia through like models, just adding the synchronous machine inertia and coming up with a number. But how do you measure it in measurements in real time, both inertia and system strength? Reactive power coordination is one I talked about. ACSCOPF, as you see, there's a lot of discussion about ACSCOPF becoming more relevant in the coming grid, because of how much the power is moving, how much constraint the grid has. So like reactive power will play its role, and we are looking for tools to do that both in planning and operation. So that the number 6 is more focused on that. Stability is obviously a big evolving topic. We are doing a lot of time domain simulation right now. We are looking for frequency scan tools and maybe different other techniques that can give us a view of stability quicker. So that is going on. Number 8 is about large load modeling, and it's one of those initiatives where there's a lot of work in large load that is happening in our business team, like all the batch process and all that. The piece that bubbled up for the grid transformation was last year when we started to talk to data centers, it was pretty clear. I think they didn't know what we are asking for, in a sense of when we say PSCAD model, what is a level of details we are looking for that, right? I mean, so we could see there's a lot of gap. We didn't want the movement of IBR where people took like maybe 10 years to have the first open source model. So we went ahead and built those models working with Texas A&M. Those are public on our website now. For crypto already is there. The data center model is already there. We'll do the electrolyzers model too. So that way we'll have all the sort of like the large power electronics load type model on our as an open source model in EMT available. So that's number 8. We are looking for machine learning and AI for OPF, power flow solutions. Number 10 is more about short circuit protection, which ISOs do not own necessarily as a thing. We don't set protection relays in ISO, but we are starting to think as we get IBR and negative sequence injection, requirement in ISO, what would be the impact on protection, right? So number 11 is more focused on power quality, given all the AI and IBRs. I think this is a topic which I feel in US has not been talked about a lot. You go to Europe and you go to Australia, they talk about harmonics and allocation harmonics a lot as compared to US, I feel this is a topic that will bubble quite a bit in future. So that's a one of interest. We are working with UT Austin on this one right now. The number 13, I would say, like we have a lot of grid farming controls. There's a requirement for battery to provide grid farming controls starting this year. And the thing we are looking here is, can there be interaction in GFMs if all 20 gigawatt battery have GFM, for example, so that's the main focus. And again, we are working with UT Austin on this. Number 14 is more focused on, can we use a single tool for prediction cost modeling, capacity expansion, and reliability analysis all in one tool so that we can transfer the model between these three tools in a correct way and do more analysis and get to the vision of 8760 full analysis for capacity expansion, prediction cost, and reliability. The number 15 is more focused on dynamic ancillary services. We do calculate based on historic numbers. We are looking for ways to do it in real time based on the forecast available as of now. The large scale EMT strategy, like we obviously have EMT models and all that, but there is one view in the industry that let's do a full grid EMT model, but we don't know if that's really needed or not. So we are working with our stability team to figure out like what should be our long-term strategy on EMT. 17 is open source data and model. So this is, I would say, is a big one. We'll have our open source data available on our website by end of the year. Power flow, market, and stability, all three. And again, these are not to say this reflects exact ERCOT model, but we'll try to make sure if we have to hand over the problem to researchers and industry, we have a way to do it, right? Because that's a number one bottleneck in any discussion. We have a way to replicate a ERCOT-like problem in this model. It's going to be 10,000 bus model and a 200 bus model both. So that would become our mechanism to make sure we reflect those problems in this model. And that becomes a common talking point for everyone. So that's where we are going with this. And the number 18 is topology optimization, more not from the perspective of removing congestion, but more from the perspective of if you have nothing else as an option and load trip is your last resort, can you do something with topology optimization to feed that load? So those are the 18 initiatives. There's a web page that you can look at all the roadmap, white papers, the open source model, large load models are all available on this website. The RIPE program is what I talked about. It's also a part of the web page. You can submit ideas, and we look at all ideas at this point. And yep, I think with that, I'll hand over. Thank you.
All right. Good morning, everyone. My name is Kerry Chung. I'm the Director for Applied Grid Transformation within the Office of Electricity, and I'm excited to share some of the activities that the department is supporting to accelerate innovation to impact. So I'll be providing a slightly different perspective from for those who don't know the Office of Electricity, really, we lead the department's efforts on grid modernization and sort of grid-related topics and issues. Our mission is to stabilize, optimize, and grow the grid to ensure that it delivers affordable, reliable, and secure energy to the American people. Our goals really help address some of the issues that the previous panelists sort of queued up, and it's really to sort of strengthen and enhance and increase capacity of the system to meet growing large loads from reshoring manufacturing as well as sort of AI data centers. It's to ensure reliability and security of grid operations with more inverter-based resources, with more dynamic conditions and extreme weather events. We're also very focused on trying to catalyze and bolster the domestic supply chain for critical grid equipment, as well as accelerating link that you can peruse. So historically, the Office of Electricity has been focused on research and development, focusing on transmission, distribution, storage, sort of hardware, as well as software solutions, data analytics, operation planning tools. With the DOE's recent realignment, the deployment functions have been merged within the Office of Electricity. And the main ones that I want to highlight is really the GRIP programs that I believe most of you should be all aware of. It's $10.5 billion across 3 program areas, supported through the Infrastructure and Investment and Jobs Act. And there's a recent NOFO that was issued from our office called Spark. It's about $2 billion that span these 3 program areas. And it's really application period closed on May 20th, and we anticipate selections in the August timeframe. Because this is an ongoing process, I can't really talk about any details of it, so just sort of flagging if anyone wants to like catch me on this later. So I want to spend the bulk of the time today talking about the Applied Grid Transformation Solutions program that I oversee, and it's really helping to serve that bridge between the R&D efforts and the deployment efforts, and really trying to fill that sort of second valley of death. So building a pipeline so that when there's a new innovations, it can easily transition to a demonstration and more easily then be scaled in deployments. And so there are 3 sub-program areas that form the strategy for this effort. The first one is Transformation Toolkit, which is mainly focused on developing tools and resources to inform decision making. There's a lot of experiences out there in industry, and if we can sort of just pull those insights together, vet those insights, and more broadly share them, we can sort of raise all boats, and that will help sort of accelerate the adoption of these innovations in industry. The second pillar is what we call testbed networks, and it's really focused on testing and stress testing innovations. When there's a new widget, a new technology that's being developed, you really need to stress test it and get the data and ensure that it performs as expected and is reliable before a utility is even willing to put it on their system for a pilot. And the last pillar is really focusing on that sort of pilot stage. What we've been hearing from industry that the term of death by pilots. When there's a new innovation, a utility needs to pilot it. Even though it's the same technology, another utility needs to pilot again. And if that's the operating model, we will not reach the scale and speed of adoption that we will need to transform this industry. And so that focus is really trying to identify solutions of how we can sort of scale, replicate, and extend the solutions that are being piloted across the US. So now I'm going to focus on highlighting some of the projects and investments that have been made in this Applied Grid Transformation Solutions program. I want to highlight the Reconductoring Economic Financial Analysis tool. This is a free, publicly accessible online tool that helps evaluate the technical economic of sort of capacity upgrade options. And so you can look at reconductoring, rebuilds, voltage upgrades, as well as transitioning AC to DC on a transmission line. The focus is really on understanding the impact of a conductor choice within these sort of upgrade options. And it's still being refined as we engage with industry and users. But we also made the underlying source code open source, and you can sort of find it on the link. The next effort, GridTechpedia, this is really meant to be an online resource for the industry. It's essentially, think of it as a Wikipedia, which highlights the technologies that are TRL 6+. I'll go into more details on this later, but it's really trying to, once again, sort of lift all boats, really trying to baseline understanding across the industry from regulators, utilities, and others on the readiness of innovations. As Eric mentioned, we're supporting the ESIG Advanced Grid User Group, and really it's about engaging with industry, learning from you all who are deploying these solutions, and how can we catalog, synthesize those insights and share it more broadly. Also want to flag that we are also looking at regulatory innovation. These innovations don't exist in silos of just from the engineering perspective. You really need to bring the entire ecosystem along. And so by promoting regulatory sandbox mechanisms, that can help pave a way for pilot and adoption of grid innovations. And so There's resources that you can find at the link, and we're currently providing technical assistance to 6 states and APPA to explore these concepts further. We've been also hearing from industry that domestic capacity for grid testing capabilities is limited, and that serves as a constraint on innovation. You really need those capabilities to test and prove out innovations before it can be adopted. But building these capital-intensive assets, it's not trivial. And so really, is there a way we can identify the capabilities that exist domestically across the nation, pull them together to see how we can sort of create that pipeline where innovations can sort of go from a lower TRL to maturation to pilot. And so there has been an initial scan across the US. We have 52 facilities identified at the grid testbed inventory. But we also had a project to demonstrate the value proposition of linking some of these capabilities that you can do more complex experiments, analysis, and simulations. Right now, we're undergoing a control room of the future testbed scoping effort, really to address the challenges with AI adoption. There's a lot of AI tools that are out there, but if they are meant to be used in an operating environment, there are a lot of hurdles to overcome, and really what type of testbed is needed to answer some of those questions. There's also been some tactical investments at the national labs to fill in some capability gaps, as well as supporting testing of innovations using some of these capabilities with an upcoming voucher opportunity. For strategic pilots, really going to sort of the Death by Pilots challenge, really from my perspective, there has to be lessons learned from one pilot that can be transferred to another. Unfortunately, a lot of those reports that are published after we fund a demonstration pilot, it's essentially like 200 pages and it's really hard to distill. And so the gamut effort is really to apply the concept of grid architecture to systematically document the operating context of a pilot so that that information can be more readily scaled and replicated elsewhere. So you can sort of decouple the regulatory context and really pull out sort of the technical merits of a pilot that others can learn from and scale. So we're in the process of developing a tool that sort of helps document these pilot projects, and you can think of it as really a TurboTax for pilot projects. We're also supporting demonstrations of grid-enhancing technologies as well as other innovations, and the hope is for these demonstration projects to feed into the gamut tool. And I think as Prashant mentioned, really, as we encounter a grid with a lot more power electronics, we need the capabilities to understand and evaluate how some of these innovations performs in a future where there's a lot less synchronous generation and sort of evaluate and understand the performance of innovations. So there's been several investments that have been made really focusing on sort of that power electronics inverter-based resource theme. So Gridtechpedia, so I mentioned this is really to help organize information that's out there, targeting regulators and utilities. What we've been hearing at sometimes there's an adversarial relationship between regulators and utilities. And so when there is an innovation that a utility wants sort of cost recovery on, the regulator has no idea whether or not that's a just and prudent sort of investment. And so really that stalls adoption of technologies. And so this resource is really meant to help address and alleviate that information asymmetry. It's a sort of neutral, unbiased perspective assessment of the technology readiness of certain technologies as well as adoption readiness. And for the adoption readiness assessment, this leverages the CARET tool that was developed by our Office of Technology Commercialization. And it really goes through an assessment across 17 dimensions across 4 areas of value proposition, market acceptance, resource maturity, as well as license to operate. Once again, recognizing that technology itself does not exist in a vacuum. If you wanted to sort of really get adopted, you really need to think about all these other issues. Is the workforce ready to maintain it? Is the capital markets available to sort of scale the solution if it's ready? And so there's a lot of great information on these resources on this resource. Right now, we have about 14 technology pages up, highlighted on the right. And really, I think the ask to this group is really if you are deploying some of these technologies and you have sort of case studies, please reach out to the team that's managing this website to share that information. If you have feedback on the contents of the tech pages, please peruse and provide feedback for accuracy, if there's nuances, if there's changes. We definitely welcome that feedback. And additionally, if you have new technologies that aren't included yet and you think are worth including, we also welcome those ideas. And finally, the control room of the future testbed project is really currently ongoing. We're engaging with industry to figure out what the needs, requirements, and gaps are. And we've had interviews, we've held a workshop at Distribute Tech as well as IEEE T&D. And really the sort of key insights that we have so far is that, adopting AI tool is not trivial in an operating environment. There's a lot of process flows, culture, regulations that needs to be sort of addressed before a tool can sort of be adopted. But at the foundation of that is really getting trust in those tools. And at the foundation of the trust is making sure that a human operator is in the loop, that you can evaluate and assess how they perform. You do not want an AI tool that looks great on paper, is an engineering feat, it can give you all this complex information insights. But if that overloads and overwhelms the operator, it will be ignored, it will not be used, and it's essentially a bad investment. And so we want to try to avoid that and ensure we have a test bed that can sort of evaluate these sort of non-technical dimensions along with the technical aspects. So yeah, the next steps for this project is really establishing those requirements, developing an architecture, and then really canvassing our national lab's capabilities to see what fits, and then determine what gaps needs to be filled so we can build out this test bed. And so we welcome engagement on this topic as it fleshes out, and looking forward to the discussion and hearing more about what's going on in the industry. Thanks.
I don't have a slide. That's the kind of fun portions of this. I get to talk without creating any slides. Anyway, my name is Didi Subakti. I'm currently serving as a vice president of system operations in California ISOs. California ISO is a balancing area and transmission operations in the western interconnection, which is really about 80% of California. But California ISO also act and is responsible as a reliability coordinators in the West Coast, in the Western interconnection. So we have a much larger footprint for our reliability coordinations as opposed to our legacy classics, California ISOs, BA and TOP area. Somewhere in there between our BA footprint and than California alone, but less than the reliability coordinator. So we have many hats when it comes to this. So when I was asked to talk about E6, and I said, well, what do you want to talk about? Well, you guys, you are in the system operation. You should tell the story about grid innovation, how it actually works, and innovation. And I said, yes, I love to tell the story. I like to tell a story. So the thing that I share with people is that the industry of electric industry has been in the past few years that I started in this industry a long time ago. It's been pretty slow, right? It's very slow adopting to any new grid technology, and rightfully so, because I think these are big
we first have our VSC DC. If you think about voltage source converter DC, that's a very old technology, and we first put it in there and have a VSC DC in 2010. And that is VSC-DC is only 53 miles in Bay Area. It comes from Pittsburgh to San Francisco. It's the first voltage source converter DC. And I remember I started in California ISO, and we were just tinkering about how that things works, and everybody was very concerned and very afraid. They don't want to be the guys that is operating on the day when that VSC-DCs actually get in service. Well, we haven't really built any new DC line and up until last year. So you probably have heard that there is new voltage source converter DC that is very large, and it's called Zanzia. Zanzia goes from and if you don't know what it is, you're not a nerdy as I am, I guess. But a collection of 3,600 megawatt of wind between the Type 3 and Type 4, and they're actually in an island by itself. They're not connected to any other things, and other connected to a voltage source converter DC, and that DC is 550 miles, I think, or 525 miles, 550 miles, and it's a 3,100 VSC DC, and that scared the heck of a lot of people, because they're basically asking the questions, well, what would happen if that DC were to trip? So they don't want to be the one that's actually operates it when that thing is that's in there, because that is one of the largest system that is in there. And while we are putting this on the commission, the transmission owner says, hey, we actually should do a fault test. Just fault test is normal. If you actually have any VSC DC doing fault test, which is live fault test, right? Where you're dangling a piano wire and you actually just create an actual fault in the line and just let it does what it does. Guess what? All the engineers were very excited and all the operators were very scared. And actually, my friends here from Arizona, they're all calling me. They actually even wrote me a letter that says, don't do that. And we're like, I got you. I understand that it's scary, but for the sake of science, we got to do this, right? we got to drop that live piano wires on the 1,600 megawatt, and we'll just drop it and see what happens. And I have a video if you want to see it. But I tell that story because it is very common for people in the operators. And I love talking with Jay because he comes from nuclear. You don't try this kind of stuff in the nuclear world, right? So we're kind of like, okay, but the bigger context that I want to share is this whole what Prashant was talking about. How do we get from a technology to operations? Because that is, I think, the challenge that we have. We have a lot of bright, brilliant people that can actually create all these innovations. And then you either go to a proof of concept or a pilot, and then you get into the control room and you get to the operations. And there is a lot of not just technical, but there is also a cultural mindset of what and where we are actually going to do this. So that is a big challenge for us in California ISO, because when in California ISOs, we have people that does all the hardware stuff or the transmission planning, and there we have all the GETS stuff, right? The grid enhancing technology, where we have advanced conductor, power flow control, HVDC, we get dynamic line rating and all this stuff that is in there. And then we have people that are doing the software portions, power system technology development, that does all our optimizations or our control, our simulation studies and all those stuff. A big part of the challenge is how do I connect those two and then have the cultural mindset and the actual change management for our people, our folks in the control room and the people around us to actually accept that this new technology is safe, reliable, and affordable. Goes back to, so I think I'm saying the same thing that again and again, and we should probably just stop and we just sit down and just actually have a discussions. So we don't have the solutions for that big transformational back to the operations. I can tell you that we have a number of things that that seems to work, but it really doesn't. So for examples, the voltage source converter DCs and all this stuff. People always ask me the questions like, Didi, how do you actually optimize, create an optimum schedule for the DC line in the LMP market? Because those DC line are transmission asset. They're not market assets. So there's no bid for that transmission line. So the question is, why is there no bid? Well, there is no bid because it's a transmission asset. So we created a bid for that transmission line so that it looks like it's an economical asset, but it's not an economical asset because it's a transmission asset. And it works for that one. So then the question then, is it scalable if we are doing it that way? Well, we don't know. The second VSCDC line is going to be coming up next. It's coming up next pretty soon here in San Jose, and we'll see how it goes. Another portions that we have all power flow controller, it's this whole notions about, okay, we could control with a phase shifter, and we built the largest phase shifter that's in there, and we could actually do that. And the question is, how do we actually want to optimize that phase shifter movement of the phase shifters? And we said, okay, we could do all the formulation that is in there, and we get very fancy and we get very interesting. And we said, you know what, we could actually optimize where the tap position is going to be. Now, if you recall, tap position is not linear, right? So then the optimization problem become very convoluted, and it's not linear, and it doesn't really work, right? But it does work, but it doesn't really work. Then we just asked, well, why are we not doing it like New York ISO? New York ISO is just linearize all this stuff, and they just hope that the tap position will give you the megawatt. And we were like, okay, we could try that. So sometimes this whole notions about it works for one item, but if you try to scale it, does it actually work when you try to scale it? We learned that similar optimizations with regard to the battery. Battery, we are still improving more and more on the optimization of the battery portion that is in there. So that's kind of our journey for things that works and things that doesn't work, thing that works through a pilot and workaround and all those stuff. Is these questions about, yes, it might work for one, might work for two. Is it scalable? And when we put it in there, how do we bring it to our operator, where all the operations engineers and the operators actually excited about it, and they would be a little bit concerned because we live in the somebody mentioned this, if your technology shows up in the news, it could be really most of the time it means bad thing happens, right? And that's something that is that you really don't want to happen. So I share this with all our engineers and our innovators, and I said, look, culturally, people in the operations always understand the fact that our risk is not symmetrical. Now, think about this, okay? Our risk is not symmetrical. Why do I say that? It's because the benefit of a success is not the same as the risk of failure. It's like if you're actually going hiking, if you're actually going hiking somewhere in a very high mountain, if you have a rock solid wall in your left side and you have a 20,000 feet jump down, which way are you leaning? You're not going to be in the middle, right? Because the risk is not symmetrical. So that's what I often share with people, is that, look, as we are moving from our idea, pilot it, and go to operational, think about scalability, think about the risk, because at the end of the day, we want to have something that's reliable, safe, and affordable, knowing that the risk is not symmetrical. All right, I'm going to stop right there and hopefully give a little bit more time for a discussion. Thank you.
All right, so we're going to jump into Q&A. Before I've got some pre-stated